Now there are actually base systems that we can use to define statically determinate systems. So there are 3 systems available to us that are always statically determinate, and we can use them to build up other systems. So we would call these statically determinate base systems. And you already dealt with 2 of them. So let me draw those 2 for you. And in total, we have 3 of them actually. So right now, I'm only going to give you the 2 that you are already familiar with. And one is the simply supported beam, because that one is a stable structural system with 3 unknowns. And then we also have the cantilever beam, which you already very familiar with, thanks to your homework. But let's understand that this here is called a simply supported beam. Simply supported beam. And then we have the cantilever beam. And you probably understand now why this is called a simply supported beam, right? Because this is as simple support as it gets without being a kinematic system and without being overstable. So we call that simply supported. And you also understand that these systems, of course, fulfill the 3 conditions: the sum of the forces in X, the sum of the forces in Y, and the sum of the moments. All of them are equal to 0. Now there's a third system which I will only draw here for your reference. We will talk in a little bit more about this, but that is a beam that looks as follows. It is kind of resembling a roof structure. And what's important about this beam is 2 things, as you will understand in just a little bit. It is having a hinge here on the top. So this here is a hinge. And now I will actually introduce a pin here, and you know that this has 2 support reactions. And I want you to think about what would happen if I were to install a roller here now. So if I have a roller here, which would look like this, then you probably understand that if I apply a vertical force here, or I push on this anywhere on the roof, this would slide out to the side. So this would not be a stable system. And this is exactly where we want to go and what we want to understand today. We want to understand what happens if we actually turn this into a pin, because then, according to our definition, we now have 4 support reactions that we have to take care of, right? So we have 2 here and 2 here. And according to everything we learned so far, we would not be able to solve this. But as you will see in a little bit, the hinge actually gives you another boundary condition. And we will talk more about the hinge as a boundary condition on the following page. But for now, let's just understand that this is called a hinged, simply supported frame. And you understand where the name is coming from. So it's the simplest form of support to a frame that is hinged. Because as I said before, if I would have a different support reaction here, then this could slide out. Or if I make it more stable, it would just not be simply supported anymore. It would not be the simplest form. But the reason these 3 base systems are so important is because you can use them to form many other compound structures. And we will see that as well on the other page. But let's for now understand that we have 3 base systems. And these are the 3 statically determinate base systems. And 3 is the number here. We only have 3, no more, no less. And we can combine these to form many different other structures. But to understand that, we need to talk about hinges, because they are used here and also when we connect them. So let's move on to the next page and talk about hinges.